next speaker. He's coming from Phoenix in Arizona today to share his wisdom and expertise with our global audience. And I'm talking about Scott Whitmire, who is a researcher at the Mayo Clinic in Phoenix. He has been an enterprise solution and software architect for over 30 years. He has developed an expertise in troubleshooting and measurement, two things that go together more often than one might think. And he's gonna share with us how enterprise architects may function as troubleshooters. So Scott, it's always a pleasure to have you here. Your presentations are always so insightful, and we're very glad that you made the time to share your wisdom and expertise with us today.
Thank you. Welcome, everybody. And today we're going to talk about the enterprise architect as a troubleshooter. And the reason this came up is a lot of business transformation efforts or change efforts start with two questions. What do I need to change? And what do I need to change it to? And to answer those questions, you have to do a little bit of troubleshooting. And sometimes it's a lot of troubleshooting. And it turns out that even when you're developing a strategy for going forward as a company, you need to do a little bit of troubleshooting to figure out what the situation is and how you might address it. So there's a little bit of problem solving that goes on. Troubleshooting is a lot like solving those algebra story problems that you used to get in high school in the US. I'm not sure what they call it in Europe, but it's those where you have a story and you have to define or divine out of the story the equation that you need to solve. And if you get the wrong equation, you're off on the wrong track and you never have any hope of getting the right answer, no matter how good you are at math. So it's partly helps define the right problem, which is the most critical aspect of all this. So the first question we ask ourselves is, what do we need to change? What about the business requires changing in order to meet future challenges or even current challenges? And once we identify what is causing our problem or what is making us unable to achieve our goals, what do we need to change it to? And then the third question is, well, how do we change that? And these are all from the book, The Goal by Eli Goldratt. And if you haven't read that book yet, it's an excellent read. It's a novel type book about the theory of constraints and how bottlenecks can move around inside of factory production. But the theory of constraints, and they've written several other books, this group has, about applying the theory of constraints to other systems, including a very entertaining story about a national health system hospital in Britain called We All Fall Down. Is a great title for a book about business change. But in a sense, that these three questions are a key, and to answer them requires troubleshooting skills. So to put it another way, what isn't performing as it should be? That's the what to change. And what new level of performance is required? So if I have processes or capabilities that are performing at some level, which one of those do I need to change or improve? And at what level do they need to be? In order to do this, you need two things. You need some troubleshooting skills, which we'll talk about today, and you have to understand the plumbing of the enterprise. And I say plumbing because it's an apt analogy in the sense that processes and skills and capabilities that you have as a business are linked to business outcomes, most of the time indirectly, and various levers that you can push in the processes and skills areas have varying degrees of influence on business outcomes. So the pipe size varies too. So that's why I use plumbing. Architects have troubleshooting skills as part of our discipline. We're trained in troubleshooting. A lot of us look at it as defining requirements. So when we want to, when a client or an employer comes to us and says we need a project to do something, or we need a solution for something, we immediately go into troubleshooting mode and say, okay, what does that something look like? What does it need to do? How does it need to behave? And that kind of stuff. And we also know the plumbing of the enterprise. We probably built it. It may have had something to do with building it. And so we know how these influences work. We know the processes. We know which ones affect the delivery of the value proposition. We know which ones are important in our competitive position because we've been working at it for a while. These necessary skills and knowledge are usually more concentrated among the enterprise architects, but not always. And they're not necessarily Hang on a second here. Can't do that. Okay, well, that's a lesson learned. They're not necessarily among your enterprise architects. Often these people have a title that has director or managing director in it. Your senior managers should have these skills. They need them to get to where they are. Sometimes they pretend they don't, and sometimes they forget. So pay attention to that. But troubleshooting is simply an instance of the scientific method. You observe what's going on. You hypothesize what might be causing the problem, what the issue is, and then you test that hypothesis. Now, this sounds a lot like debugging. You use the same technique when you're debugging code. Use the same technique when you're trying to solve a problem in science. And the scientific method has a formal name and a formal process. And the more formal you are about doing it or executing it, including creating log notes or experimental notes, the more effective you can be in the long run. I once had a class in debugging code that talked about using detailed lab notes. I started taking detailed notes at that point, and that was almost 30 years ago now, and haven't quit. So it's an exercise. You understand when you write stuff down, and I use handwritten notes. I don't take notes on a computer. I tried that. Doesn't always work. But when you handwrite things down, your mind internalizes it much better. So it's a lot easier to learn when you're handwriting notes than it is when you're typing it in on a computer. Now, it's a lot easier to get to when you type it in on a computer, granted, but you don't necessarily need to go back to it. You just need to write it down and you remember it better. So this is like a wash, rinse, repeat kind of exercise where your first hypothesis will probably be wrong in the sense that you'll be easy to disprove it. Now, understand the plumbing a little bit. The process performance, and I'm talking potential performance, things like capacity, cycle time, the defect rate, the cost of an activity, the stuff that doesn't change with business activity, that requires an investment in process change in order to influence these measures. You can't, in other words, you can't increase the capacity of a process without investing some money in it. You can't speed up the cycle time without investing money in it. You have to change things. So these are the kind of performances we're looking for. These are the structural measures that Chris Potts talks about. And he talked about structural ratios, which took some of these measures and applied activity to them. But I look at the base measures themselves, and there's 5 common ones, and I named capacity, activity cost in minutes. How long does it take to do something in minutes? The defect rate, how often are defects generated by the process, at what rate? The activity, the cost structure, in other words, the mix of fixed and variable costs, has to be, you have to make an investment to change that. And those investments are typically made as you increase activity to the point where your variable costs become too great and you need to reduce those. And the other one is cycle time. Stakeholder experience is linked to business outcomes. So we're talking customer experiences mostly here. So your processes deliver your customer experience. Your customer experience influences your business outcome because the experiences your customers have convince them to either come back or go away or go somewhere else. And the harder it is to do business with you, the less likely they are to come back. Some links are direct. These are your value delivering processes, the customer touch points, the processes that terminate in a customer touch point, a customer experience, for example, such as your website, your online store, or a salesperson on the sales floor in a retail outlet. Most are less so. I put the hiring pipeline in here because in one particular employer, the indirect cause was the actual bottleneck in a process. I used to work for Nordstrom, and at the time they'd published a goal to open 300 of their discount rack stores every year. And they had the real estate, they had the store managers, they had the inventory all lined up and ready to go. What they didn't have were department managers. And what they did for those is they borrowed assistant managers from existing stores, assistant department managers from existing stores, to promote them to department manager at a new store. Problem was, they didn't have any assistant managers because they'd been using them for new stores so fast, they couldn't replace them. So the assistant manager hiring pipeline was the actual bottleneck that limited the ability to open rack stores. Now, it turns out the economy went bad at the right time so that they didn't have to fix that. But in order to achieve their goal, they would have had to change that. These links are what I call the plumbing. And the influence can be plus or minus, good or bad. And some processes have more influence than others, and hence the plumbing analogy. So, in a sense, fluid in the pipe can flow either way, good or bad, or more fluid versus others. So you can have higher pressure, lower pressure, higher flow, lower flow. So there's a degree of influence there. And these are your 5 process capability measures, and you can measure both a process or a capability, the one using any of these, because the capability is has all the skills, tools, and knowledge necessary to execute the process. The process is simply how you package your capabilities and implement them. Again, capacity is the maximum throughput. What is the absolute limit? Usually in terms of minutes. In a capacity or a process that has people involved, it's how many minutes are available per month or per quarter to execute this capacity. So if you have a customer credit check, for example, that requires people in your credit department, you might have 10 people that have so many minutes available. The example I like to use when I train on these measures is the shipping department, where you have 28 full-time employees, and there's roughly 675,000 minutes a quarter available. Now, in order to get more minutes, you either have to pay more or hire more people. So capacity changes require investment. Activity cost is how long it takes to do something. How long does it take to pick and pack a shipment? So many minutes per item plus so much time to box it up and do the paperwork. So there's a fixed cost associated with that, usually 5 minutes or so plus a minute or 2 per item. What's the cycle time? This is the end-to-end time for the process, including wait time and delay. And wait time is like waiting for paint to dry when you're in construction, or you're waiting for cement to cure. It's unavoidable time that you have to wait for some process to execute on its own. Delay is you're waiting for somebody to make a decision. So when it goes onto somebody's desk, it goes down to the next party in line, and it sits there in a queue. That's delay. Now, the typical process improvement exercise was to remove the delay of production processes. That's where it started, but it focused on all processes at some point. So you can reduce the delay time, you can reduce the activity cost, but all that requires investment again. Defect rate is one of your more important measures. This is the rate at which defects are created as you execute this process, and it's usually expressed as a number of defects per some number of opportunities, usually million opportunities. 6 sigma is 3 defects per million opportunities as a rate, and that is the target defect rate for a high volume production process. Now, a lower volume process might be per 1,000 opportunities or per 100 opportunities, depending on how many times you execute it. You want to use a number that falls between 0 and 10, and so you adjust your numerator power of 10 to accommodate that. But that's just ratios, and so the defect rate is inherent in the process. Now, as activity goes up, the number of defects will increase, even though your defect rate stays the same. If your defect rate starts to go up, in other words, it used to be 3 per million opportunities, and now it's 4 or 5. Probable what's going on, or there's an indication that something's going on, and the process is being stressed. And typically what you'll find is that you're approaching your capacity, and as you approach your capacity, stress occurs and mistakes start getting made because people get rushed in doing their job. And then again, the cost structure. This is the fixed versus variable cost, where you start out with your fixed costs are the money you spend to enable that process, even though there's no activity. So regardless of the level of activity, there is fixed cost. And variable cost is how much it costs per unit as you produce. And you can plot that on a curve. So at 0 activity, and I'll show you a cost curve here in a second, you have your fixed cost, and then it goes up from there based on your variable cost and the number of units, and it's usually a straight line. The problem is that sometimes you have to change your cost mix because of wide variations in activity. If you have a high volume process and you have low fixed costs, which means that you're probably labor intensive, adding more capacity requires adding more people, which can be very expensive. So you have high variable costs, and so your total costs then start going up rapidly. You make an investment to automate something. What you're trading is some amount of variable costs for a less fixed cost. And so that you can sustain that because your level of activity is above the break-even point of this fixed cost, and so you do that. Now, if you go the other way and you reduce activity, sometimes you have to turn that fixed cost infrastructure off. And almost every automation process or activity is an exercise in trading fixed cost for variable cost, or variable cost for fixed cost, depending on what the automation is doing. These all require investment to change, which means they don't change on their own, and these are the only things you can change, or these are the things you want to change when you do a process change. So you start with your goals, and you find the processes and capabilities that have the most influence over achieving these goals. What's the biggest contribution? What's the biggest impediment? What's your biggest resistor? You have a current level of activity, and you might make your initial measurements at this point, because you might not know what the capacity is or the cost structure is. So you might calculate those right now. And once you identify what your processes are, you're focusing on, and then you determine the level of performance you need. So in order to achieve my goal on this some process, say shipping, I want to increase my business, I'm going to have to increase the shipping capacity by 20%. Well, how do I do that? I can add more people, or I can make some other change to it to reduce the cost of the activity, maybe by automating something or providing less paperwork or something that you can make a change that allows the same number of people to do more of the activities with the capacity. So you reduce the cost, you increase your capacity in effect with the same staff size. I used to tell people when we were automating things, and you know, I don't save any money. That the client would say, I don't save any money until I fire somebody. And I said, no, the same two people can do twice as much business. You've actually increased your capacity by doing that. So that's an example of increasing capacity by actually reducing the activity cost. You might need to decrease the defect rate or cycle time, depending on the nature of what the process requires or what the goals require for the process. And then you can determine how much investment is required to get from the current level of performance to the next level of performance. And hint, it could be a lot. These are sometimes very expensive things to do. So here's the example cost structure I showed you. Look at the blue and green lines right now. So this is a sample current. You can see the current capacity is 4,500,000 units. So 4.5 million units per year, per year. And the fixed cost is roughly about 20, it looks like. 20 million. The variable cost in this case starts at 1.5 million and runs up. So at 4.5 million, it's about 80. The total cost is about 80 million per year. So your variable cost is 60. And then you can see that it's growing at a fixed rate. The investment process, our project, is to automate some activity or some set of activities within this process to increase the fixed cost from the blue line to the yellow line. So go from about 24 to about 23 or 24 to 26 or 27 or whatever that number is. And then you see that the fixed cost, the new total cost, is the red line, so that the variable costs reduce such and such that they grow a lot less. So we've actually improved this process to the extent where it's a lot cheaper to run higher capacities. So our target capacity is out there at 6 million units, and you can see that the that the total cost is going to decrease from 100 million a year to about 70. So that's a net savings of $30 million a year by trading variable costs for fixed costs. And this is just an example of what happens. And this kind of stuff goes on all the time in companies, all large and small, all over the place. As you buy a new machine tool, it's going to automate some work or make work faster. This is the curve you're actually looking at. So when people talk about cost structure, this is what they're talking about. And it requires an investment. It's not easy, and not everybody's going to know what the cost structure is. You can apply this cost structure concept to a number of things. I remember I was working at T-Mobile when they announced that they were going to be acquired by AT&T, and this merger did not go through. But it was about a year that they were dinking around trying to figure out whether it was going to work or not. And right after they announced the merger, we came back together, the enterprise architects and the senior engineers in the company got together, and everybody was going, I don't want to work for AT&T. This is terrible news and so forth. And my comment was, that's not the worst that could happen. That's the worst that could happen is this merger doesn't go through and we're cut loose because the parent company's already told us they don't want us. And our cost structure is such that we can't do what we need to do. We can't invest in the network and generate a fair return to shareholders. We can do one or the other, but we can't do both. And we were taking money out of the parent company to invest in the network and return a fair fair return back. So we were borrowing money to do both, but on our own we couldn't do that. Well, sure enough, the merger did not go through. T-Mobile was cut loose on its own, and it struggled for a couple of years. They got in a new CEO who turned the place around, and now they're booming. But it was a tough couple of years, and so the prediction was accurate. That's what I have for you today. We've talked about troubleshooting and what it means. I will say that troubleshooting can be learned. It's not easy to teach it, but it can be learned. And mostly it's an apprentice type situation where you watch people do it and you learn from that, because it takes a lot of creativity. It takes deep knowledge of the system. The best troubleshooter I know, as an example, popular example, is Mr. Scott from Star Trek. And he could tell one episode he smelled something funny. He says, something wrong, it doesn't smell right. And so he went in and started troubleshooting what was going on. The engineering mate or the chief engineer on a ship will know by the sound or the feel whether things are working properly. And when something's out of whack, they'll start noticing, and the hair in the back of their neck will stand up, and everybody go, what are you doing here? This is weird, you know. But they understand their systems, and so you can look at that. Those of us who run enterprises, who monitor the operation of enterprises, can tell when something starts to go wrong, or what might need to change. We were at Nordstrom, and they had a goal to increase their double the revenue they were achieving from their online store. It was about $1.5 billion a year, and they wanted to go to a little over 3 or almost 4. So it was more than double. But we noticed that they had recently instituted free shipping and returns, and we noticed that return rate nearly doubled from about 15% to over 30%, which was expected, because what happens when customers were buying 3 and 4 sizes of the same thing, trying them on and keeping the size that fit the best and send the others back. And that was actually something we wanted them to do, because they were buying more stuff, but they were returning a lot. But we also noticed as the volume went up in sales on the online store, the return rate started creeping up, and it was creeping up around 40%, headed for 45%. And we extrapolated those two curves out and concluded that if we achieved our goal of doubling net sales, the return rate would be close to 50%, which meant that the number of transactions that had to be processed by the online system would increase by a factor of 8 or 10. And I asked one of the solution architects, I said, just out of curiosity, what would you do if you were told that in a year you had to be able to support 10 times the number of transactions you do today? And his face turned white, and he said, we couldn't do it. We'd fall over at about 6 times. And so at that point, we knew right then that there wasn't a problem yet, but as business increased, there was going to be. So we knew where it was, and so that the website had to increase, or the web infrastructure had to increase its capacity significantly in order to achieve these goals. Fortunately, we found out ahead of time, and they were able to make those changes over the course of several years. And that was, but if we hadn't done that calculation and asked that question, they'd have run into a brick wall because nobody would have known about that. With that, I'm going to
Excellent, Scott. So yes, if you could stop showing your presentation screen, I'll come back onto the camera here. And there's time still for those of you who did not enter your questions to submit your questions. So Scott, let's start with a few of the themes that you have brought up here. Of course, there's a great case study that just happened yesterday on Facebook, Instagram, and WhatsApp coming to its knees. And I'm sure there's some stressed out enterprise architects and those in the company trying to figure out what's going on. That's some big troubleshooting going on. What is your thinking about, you know, when things like that happen in terms of enterprise architects and troubleshooters, what they do?
Well, there's a lot to you know, firefighters and tag teams are like that. I remember we were working, we were a contract company working for a warehouser supporting an application, and occasionally our computers would lose access to the warehouser network, just totally go blank. Eventually figured out that every time somebody modified the routing table, they would lose the routing table, and then they would lose our whitelist access, and so they wouldn't restore that. So we finally got them to take care of that problem. It took 3 tries. So my first thought was, when Facebook went down, was somebody lost the routing table. It turns out that that was pretty close to the right answer, and the reason I came to that conclusion was there aren't many things that cause all your systems to go out in multiple data centers, because I know that they're distributed worldwide. So when everything goes down at once, it's something in a configuration. It's not physical. It's not. So a data center didn't go down because they would have had to be multiple simultaneous failures, and that just doesn't happen. So somebody did something in configuration, and their internal systems also went down. So whatever they did took out their domain name service, and we found this out yesterday, and that took out everything else. Domain name service is actually quite vulnerable to outages because it's so relied upon, and most companies, Facebook I think has 2 domain name servers that people connect to get to their internal systems, but their internal systems also require fully qualified domain names, which require a working DNS. And when that went down, they were kind of stuck. So they're now working on doing that. It was a configuration table in the I think they found it in the internet, access to the internet from their data center. So it was in that join between their data center and or their system and the internet. Now they have multiple physical connections, but the configuration table went down. So it was something they did to themselves. So the people who were maintaining that, network engineers, were scrambling.
Yeah, I'm sure that there is going to be a lot of lessons from that, and it's of course very suspicious also that everything that's going on in the media with the company and something like that happens internally at the same time. It's you know, you can worry about cybersecurity issues, but also internal security issues that may be something done from inside. But time will tell what happened there. On the subject of troubleshooting, again, one of the themes that has come up, which is an interesting one, you talk about some very foundational items here related to measurement, related to the scientific method and how to approach problem solving, and also the, you know, the expectation that enterprise architects, you know, they are pretty good at troubleshooting, especially when you get to a certain point in experience in your career. You've done quite a bit of troubleshooting. Some of it was almost intuitive, and some of it was more methodical, if you will. Now, there is a perception that came up on the comments that if you work with some software developers, it's like their method of troubleshooting is trial and error. You know, they can type faster than they can think about what they're doing. We've all seen this. It's like, well, you know, something goes wrong and say, oh, I know what you're doing. And they start typing, and that crashes something else, and they type something else. And it's like, when do you take that time, step back and say, let me try to understand what's going on here before I start trying these solutions? What has happened, I guess, when it comes to software engineers and related professionals, that it seems like we're maybe lacking a little bit of the discipline of troubleshooting, and or is it try and error is the new approach?
Usually when people do trial and error, they have a couple of ideas what it might be, but they haven't really thought about it. It was just, you know, a guess, and so they want to try and see if that's what it is. After about the third try that doesn't work, you start to stop and think about it. When the cost of the test is high, in other words, you have to change a lot in order just to make the test. In other words, I think I know it's wrong, but in order to do that, it's going to be several hours worth of work. You tend to stop and think about it first and think it through, so you have the discipline at that point. If it's a quick little change, a couple of lines of code, I'm adding a print statement or something like that, you know, that might work out for a while, and you get more information. And sometimes that doesn't work in a C or C++ program. Adding statements to print out results of variables, or looking at a debugger, can actually change the behavior of the program because it's a pointer problem. And in fact, in C and C++, it's a pointer problem until proven otherwise. But you know, what is going wrong somewhere usually requires some more information. So these typing and testing is mostly to get the information, the extra information, what is going on. Because I know what the code's supposed to do. So what are the values of the variables going in that shouldn't be that way, and where are they going into? You do this enough, and if you've built a complex system, you can pretty well tell where the problem is and probably what's going on, but you might have to run a couple of experiments to check that. So that's kind of what's going on there, is that they have a pretty good idea. It's not, sometimes it's trial and error, and sometimes it's not. Sometimes it's just going in, I know where to look, and I need some specific information. And so I'm just putting in some statements that'll tell me what's going on, and then they'll confirm or refute the hypothesis. I do that occasionally because, you know, you get the same errors over and over again happen, and it's the same kind of thing. I deal with medical images, and they tend to fail in certain ways, and it's usually data in the image itself that's not quite right. And so after a while, it's, you know, one of these 5 things. So let's go check them in the order that they occur.
Do you feel that that we are doing a good job on educating software developers, engineers, enterprise architects on the discipline of troubleshooting?
No, not at all. I recently wrote a book on engineering software called Engineer Your Software, and the book was written, and I work in research, and the book was written for people who have to write code as part of their job but aren't trained software engineers, so they don't do it for a living. The code in research is basically atrocious. If it works at all, it's hard to use, it's impossible to reuse. And this is even true of tools that are open source, that are funded, labs that are funded to write software. Think DICOM for Che or XNAT, which are these tools that are out there that are just difficult to use, hard, fragile. So we don't do a good job of we teach programming so people can write code when they get out of computer science or software engineering programs, but we don't teach systems design. We don't teach troubleshooting. One of the prerequisites for becoming an architect is some modicum of troubleshooting skills. So that's sort of baked in to the people that we certify as architects, at least currently. But there aren't that many people who are good troubleshooters in the world. I'm guessing 5% maybe have that skill innately. The joke is that there are 3 kinds of people in dealing with an automobile accident. They're the kind that look at an accident, see an accident, and look away because it's too gross. And then there are kind of people that look at an accident and get all enraptured by the gore and the blood and and so forth. Those are the horror movie fans. And then there are people who go, well, how'd that happen? and those are your troubleshooters.
Yeah, I think naturally they are a bit of a rare breed, but as you
Maybe
pointed
learn
out, I mean, we can certainly do a better job at educating them on systems thinking and understanding maybe more
right.
disciplined approaches to troubleshooting. Is there any methodology that you have found to be more useful, you know, from the old PDCA, you know, or to the MAIC, the MADVIN, Six Sigma, Lean principles apply to this area? Is there any methodology that stands out as useful to you when it comes to troubleshooting?
Sherlock Holmes and House MD. Both are exercises in troubleshooting. The scientific methods used, detectives use the same thing to solve a crime. But what you learn there, if you looked at, other than the drama going on between the characters, if you looked at an episode of House MD, every episode was an exercise in trying to diagnose a patient with some difficult condition. And the process they used was they would identify all the symptoms they've observed, write them down on a whiteboard, and then on the next line over, on the next column over, they would identify all of the diseases or all the conditions they know that create any one of those symptoms. And then they'd go through an exercise where they cross out diseases that generate symptoms that they're not seeing but are required to be part of the disease. So it's a required condition for this disease, and this requires some medical knowledge. So, you know, what causes are there that create this symptom, but also create other symptoms that we're not seeing? And so we cross those off. And so, like Sherlock Holmes used to say, when you eliminate all of the possibilities, what's left, however improbable, is the right answer. And that's really the formalization of troubleshooting is what am I seeing? What can cause that? What causes things? What on this list causes things that I'm not seeing that have to be there in order for it to be this condition? Cross that off because it can't be that. Or look for that other condition and see if that's there and I just missed it. So there's another thing there. So there's a formal process of here's what I got, here's what causes that. And so medical diagnosis and detective work are probably the best frameworks for learning how to troubleshoot. And Holmes makes it more visible than anybody else. He just explains the process. So that's why that's a good example.
That's a good one. That's a good one. And Scott, another thing that came up in the comments is related to your emphasis on for enterprise architects to be good troubleshooters, but you also make a case for them to understand value creation in the enterprise. And I think that that's often overlooked in enterprise architect type of roles, that we know how things work, but we haven't thought through how they create or destroy value for the organization and for its customers. In your discussion on costs and understanding the different types of value add or destruction is very useful. I wanna confirm. Do you see that somewhat lack of awareness related to value creation, destruction in the enterprise, an area of weakness when it comes to enterprise architects?
Yes, that's certainly an area of weakness, and that's one of the things you have to learn differently for each company, because the value creation process is different in every instance of a company. If you look at the high level processes, all banks, for example, have the same level 0 process, the same basic capabilities are required. What's different about them are the ones they emphasize for their various competitive positions. And in a particular bank, you would need to know what the value creation process is for, and the value propositions are different. Some is I want to provide services to my customers. Some is I want to make them wealthy. You know, depending on what your value proposition is, some processes and capabilities have more influence on that, and you need to learn those because those are what's driving the business. And probably will be most likely to show stress as you approach a capacity limit. So you need to know where to look first. That doesn't mean it's always going to be there. It's just that's the first place you look.
For sure. So final question here is that what advice do you have for maybe a team, a department, maybe an entire organization that wants to build maybe a bit of a culture of troubleshooting and to really go for root causes and understand those root causes and fix them. What are some suggestions you have for organizations or small teams to develop these capabilities?
I would start by getting very deliberate about it. A small team of 6 or 8 people can actually do what the team on House MD does, and that is take a whiteboard, write down all the things they're observing. These are the conditions that we're seeing right now in terms of our defect rates are going up or something happening, some indicator. Usually a lagging indicator, a business outcome indicator is flagging, profits are dropping, even though revenue is increasing, something's going on. And then identify what might cause that by looking at the processes, the level 1 or level 0 processes in the business, and saying where might that be occurring? What has the most influence on this particular metric that's not working? And just follow that exercise through and be very deliberate about it. After a while, it becomes second nature, and anybody can follow it. It's just a matter of taking the time to do the actual visible steps to make that work. And so I would start there.
Excellent, Scott. Thank you so much. I know it was an early time in Phoenix for you today. We appreciate you joining us and in our focus on enterprise architecture in Europe. And on behalf of our global audience, very grateful for you to share your wisdom and expertise in this very important area.
Thank you. It's been a pleasure. I like these conferences. Look forward to another one.
Likewise, Scott. Ladies and gentlemen, Scott Whitmire here with us. Research Manager, Systems Architect on the Precision Neurotherapeutics program at the Mayo Clinic. Always a pleasure to have him sharing his wisdom and expertise with us. Now, we're going to set up for the next session that starts at the top of the hour. And on that, we're going to be welcoming Satish Kamath, who is the lead enterprise architect for Mars Wrigley and corporate functions. And he's an accomplished technology leader who is enabling culture, business, and digital transformation at large multinational corporations, and specifically at Mars Wrigley and corporate. They have been on a fantastic journey. He's going to share the role of enterprise architects and architecture on that journey. So you do not want to miss that session. We started back up at the top of the hour. Please do take a break now, and I'll see you back soon.